All right, our last unit of this chapter, solubility. Now we've already talked a little bit about solubility when we decided or determined the state of matter of compounds. Do you remember the solubility rules? There's 6 of them on the back of your periodic table. And if something was soluble, that meant it dissolved. And we put a little AQ after that compound. So aqueous meant that it dissolved. It was soluble. So solubility deals with how things dissolve in water. Well, generally water. I guess it doesn't necessarily have to be water, but I think 9 out of 10 times it will be water. So starting off with saturation, solvents, again, generally water, can only dissolve so much solute. There's a maximum amount of solute that any liquid, probably water, can dissolve. Once you reach that maximum amount of solute, we say that our solution is saturated. So here's 2 examples. We have 100 milliliters of water, and we put 30 grams of sodium chloride, that's table salt, that'd be our solute, into that water, and it dissolves. So there's none left. We'd call this an unsaturated solution. So it's not full. Un meaning not, saturated meaning full, so unsaturated. If we were to put 40 grams of salt into 100 milliliters of water, most of the salt would dissolve, but some of it will filter out to the bottom. We'll have some salt on the bottom. It isn't because sodium chloride isn't soluble, it certainly is. We dissolved most of it. It's just that the solution is full or saturated. This is a saturated solution, and we'd have some amount of sodium chloride left over on the bottom. 4 grams in this example. So there are 3 ways we can increase the dissolving rate of a solution. So not necessarily dissolving how much you can solve, but how fast, how quickly you want to dissolve it. So you put some sugar in your tea. Well, how do you want to dissolve that sugar? Well, you can speed it up by doing one of these 3 things. Number 1, stir. I think we're all probably familiar that you take a spoon and stir in the sugar into your coffee or tea. So stirring. We could also say just agitate. So shaking would be the same as stirring. If we put a sugar cube into a bottle of something, we would shake it up to speed up the dissolving of that solute. We could increase the surface area of the sugar. So they've got a picture of a big cube of sugar there. Here's some big cubes of sugar. It's going to take longer to dissolve these larger cubes than smaller, tiny pieces of sugar. So increase the surface area, smaller pieces, and it will dissolve faster. You have more interactions with the water, so it dissolves, it gets pulled apart quicker. The third way is to increase the temperature. So increasing the temperature will speed up how fast your solute will dissolve. Now, quick note here, increasing the temperature also increases the saturation point. So if you were given those 40 grams of table salt that we saw in the previous problem, and you were asked to dissolve all 40 grams, your best bet would be to heat up the water. Warmer water can dissolve more total solute, but it also increases the rate. So the first 2 don't increase how much you can dissolve, just the speed of which it dissolves. So stirring and smaller surface size don't increase how much, they just increase how fast. Temperature both increases how fast and how much. And that leads us to the crux of today's lesson, solubility curves. So we show the solubility of different salts with graphs. Looks something like this. So how much sugar or salt can we dissolve in 100 grams of water based on the temperature? So again, as the temperature of the water changes, the amount of salt that you can dissolve also changes. So anything below this line represents the maximum saturation of whatever salt you're working with. The red line has potassium nitrate, KNO3, and the blue line represents sodium chloride, NaCl. And the line shows us where the saturation point is. So at 30 degrees, that's close to room temperature in Celsius, a little warmer than room temperature. We follow that up, and for sodium chloride, NaCl, we'd expect to be able to dissolve almost 40 grams of salt, just under that 40 gram mark. For potassium nitrate at 30 degrees, we'd expect to dissolve more. See how the saturation point is higher? Follow it up, hit the line, follow it over. We'd be in the neighborhood of closer to 50 grams of KNO3 per 100 grams of water. And this is important. Watch out for that 100 grams of water. A lot of questions will try to trip you up by saying, what if you have 50 grams of water, just 50? Well, you'd have to have the amount of salt. So if we found that we could dissolve 40 grams of NaCl, but it was only 50 grams of water, we'd want to divide that by 2. I think we'll have an example of that in a few slides. Once you reach that line, so anything up to that line, and you have an unsaturated solution, so 20 grams at 30 degrees, both solutions are unsaturated. Once you reach the line, so here we are at about 38 grams, we'll say, sodium chloride is now considered saturated. Because we're still under the red line, we'd say potassium nitrate is unsaturated. As we continue to increase how much salt we add, it doesn't change anything. Sodium chloride still saturated as we go up to 50 grams. Now we have potassium nitrate, it's saturated at about 50 grams. We go above that, we get to 60, 70, 100 grams. Both solutions would be saturated. Again, make sure you guys are noticing as the temperature increases, so too does the amount of salt that you can dissolve. Now, sodium chloride doesn't increase by much, but potassium nitrate definitely does. That one's shooting up. It started much lower than sodium chloride. At 0 or 10 degrees of water, you can't dissolve very much potassium nitrate. But as that temperature increases, the amount of potassium nitrate you can add really shoots up there. All right, so that last solubility curve that we had only had 2 lines on it, only potassium nitrate and sodium chloride. Most of the time, we're going to be looking at a more complex graph that has a lot of different salts on it, kind of like the graph here on the right. And you'll notice each line is identified as a certain or particular salt, and we still have our amount of salt per 100 grams of water. So again, make sure you guys are watching that. They can change that number on you. And the temperature of the water, which should always be from 0 to 100. If you give it a thought, you don't really have liquid water below 0, and you don't have liquid water above 100. So this will probably always be a 0 to 100 degrees Celsius graph. So types of questions you'll see are like this. How many grams of sodium nitrate can be dissolved in 100 grams of water at 40 degrees Celsius? All right, I'm looking for sodium nitrate, NaNO3. So that's this line up here. There's my sodium nitrate. I find 40 degrees Celsius. That's this line here. We follow it up until we hit the sodium nitrate line, follow it over, and we're going to be in the neighborhood of 110. 105 grams of sodium nitrate can dissolve in 100 grams of water at 40 degrees Celsius. At 50 degrees Celsius, is 100 grams of potassium chlorate saturated or unsaturated? All right, so same type of question, asked a little bit differently. So we're asking, is it full or is it not yet full? So let's see, KCl3. Here's KCl3, here's the line, it's going up. At 50 degrees, the saturation point of KCl3 is a little above 20 grams per 100 grams of water. So 100 grams of KClO3, well, heck, that'd be way up here. That's way above the line, so that is definitely a saturated solution. That solution would be full, more salt than the water can dissolve in it. Saturated solution. A saturated solution of KCl is formed if the solution is dropped from 60 degrees to 20 degrees. How many grams of precipitate will come out? Okay, so at 60 degrees, we're going to saturate potassium chloride. So here's my line for potassium chloride. At 60 degrees, I'm right in this neighborhood here. So we'll call that about 45 or so grams can dissolve at 60 degrees. If we drop the temperature to 20 degrees, we can only dissolve a little over 30. So 45 minus 35 grams gives us 10 grams of KCl will come out of the solution, will no longer be dissolved. We would say that precipitates out of the solution. You can see those salt crystals come out and probably fall to the bottom of the beaker. 110 grams of sodium chloride is at 90 degrees Celsius. How much is dissolved and how much is undissolved at the bottom of the test tube? Okay, so here's 90 degrees. Sodium chloride, will follow that up until we hit the line. Here's sodium chloride. Looks like at 90 degrees we can dissolve about 40 grams of the material. We have 110 grams. So if 40 grams are dissolved, how much is undissolved? Well, 40 and 110, we subtract 40 dissolved from 110 total, and we get about 70 grams undissolved, probably sitting at the bottom of the test tube. One more thing I wanted to point out. Remember I told you most salts are going up with an increase in temperature. Notice the two lines that go down. This line and this line. And I guess technically HCl. Perhaps you remember, perhaps you don't. HCl, NH3, and SO2 are all covalent bonds, whereas everything else is an ionic bond. Do you remember the two nonmetals, H and Cl? N and H, S and O? They're all nonmetals, so these are covalent molecules. They're not salts. They actually would be gases if they were not dissolved in water. So think of carbonation like in a soda pop. Bubbles of carbonation. Carbonation is a gas. So HCl going down, NH3 going down, and SO2 going down are all gases on as elements, or as compounds, excuse me, not elements, as compounds. They're all covalently bonded molecules that are gases, and because they're gases, their solubility actually decreases. Most of the time we work with salts that do dissolve, that are soluble, and their solubility increases. But I wanted to make sure you guys noticed those downward moving lines and understood that those were gases, and that's why they're downward moving. All right, had a few more examples if you wanted to pause the video and work through these to see if you're doing it right. This graph has a wonderful set of colors to it. Hey, look, there must be another gas there, cesium sulfate. All right, which salt is least soluble in water at 10 degrees Celsius? So we find 10 degrees up, get a nice arrow for me there. Followed up, looks like potassium chlorate. KClO3, we've run into that line first. It is least soluble in 100 degrees water at 10 degrees. How many grams of potassium chloride can be dissolved in 200 grams of water at 80 degrees? All right, so we find 80 degrees Celsius. There we are. We follow it up. It looks like it's just above 50. So we said 51, 52, 53, somewhere in that neighborhood. Now here's the catch. It's 200 grams of water, not 100 grams. Remember, the graph over here shows us per 100 grams. Hey, that's not a problem. All we have to do is multiply the value we got by 2. I got about 104 total grams can be dissolved in 200 grams of water. Again, if it's 52 grams per 100 grams of water, if I double that, I get about 104 grams in 200 grams of water. Next question, at 40 degrees Celsius, how much potassium nitrate can be dissolved in 300 grams of water? So here's my 40 degrees. I follow that up until I hit my line of potassium nitrate. It's the green line here. Looks like I can dissolve roughly 65 grams. If you said 64 or 63 or 66, I'd be fine with that. But again, notice we have 300 grams of water. So we need to multiply that value by 3. And we get 192 total grams. A saturated solution of potassium chromate. So here's my potassium chromate, potassium, and here's chromate. A saturated solution of potassium chromate is formed in 100 grams of water. If the saturation is cooled from 80 degrees Celsius to 50 degrees Celsius, how many grams of precipitate are formed? So at 80 degrees, we can dissolve just under 60 grams. So I'll call it 56, 57, 58, somewhere in that value. If we drop the temperature down to 50 degrees, we're now here around 30 grams. So 58 grams at 80 degrees, 30 grams at 50 degrees. So we subtract the two, and we're going to guess about 28 grams should precipitate out. 28 grams should become undissolved. The word for that is precipitate. Approximately, how many grams of sodium nitrate will dissolve in 100 grams of water at 10 degrees? So 10 degrees, 100 grams of water, sodium nitrate, here's the line. It's like about 80 grams of sodium nitrate can be expected to be dissolved at 10 degrees. 90 grams of potassium nitrate is added to 100 grams of water at 0 degrees Celsius. With constant stirring, to what temperature must the solution be raised to produce a saturated solution with no solid KNO3 remaining? All right, so we want to be right on the line. We don't want to have any solid sitting at the bottom. So we'll be right on the line. So here is our 90 grams of KNO3, 100 grams of water at 0 degrees. We want to dissolve all 90 grams. So we have to follow it over. Where do we hit the line? Right in there. Looks like about 50 degrees. So we're going to have to heat our KNO3 temperature from 0 to 50 degrees, 51 degrees, perhaps just over, to make sure that we dissolve all of our KNO3, our 90 grams of KNO3, to make a saturated solution. If I continue to go much past 51 degrees, at that point KNO3 is going almost straight up here. Look at the slope on that line. If I went much past KNO3, or much past 51 degrees, I would no longer have a saturated solution. If I went out to 55 degrees, look, I'd be 10 grams shy of a saturated solution. So make sure you stop right at 51 degrees for that solution. I think I mentioned in class yesterday, this is a combination, a homework for tonight, but also your test review. So this first page here are a lot of review type problems from what we did before break. And then the second page here is kind of a homework that should go with today, material from today. So take a look, page 1, page 2, spend some time on it. We've got the test on Thursday.